Alright, from here, still on maximum power transfer, example 2, our next example. The question says that find the value of the load resistor, right? You are given this circuit. This is our example 2. This is example 2. Given this circuit, the question says that find the value of the load resistor, meaning RL, that gives the maximum power dissipated, right? And determine the value of this power. So what this question is saying is that we are given this circuit, we are told to find the value of the load resistor. After finding the value of the load resistor, find the value of the resistor that gives the maximum power transfer. You know, to know the value of your maximum power transfer, it depends on the value of your resistor, right? Having concluded that this is the value of the resistor that will give you your maximum power transfer in any source, then you use the formula for your power, which is what? P equals to I square R, right? But from here, looking at this diagram, this circuit diagram is quite different from the diagram of maximum power transfer. So first thing first, you know, each theorem have their own diagram and their own mathematical formula. So given this question, first thing first, we are under maximum power transfer. So draw your circuit for maximum power transfer. This is your circuit for maximum power transfer, right? You have this diagram. This is your source. Sorry, this is your cell, right? And this is your internal resistance. And this is your load resistance. And to get your maximum power transfer, your load resistance, okay, your internal resistance R must be equals to what? Your load resistance. This is your circuit. This is your circuit diagram. Now, what it means is that given this circuit, my task here is that given this circuit, I must reduce this circuit to something of this nature. I must reduce this circuit to something of this nature. Meaning, given this circuit, I must know, meaning from this circuit, I want to know, say this is your source. Say this is your source from this circuit. Say this is our source. Meaning from this circuit, I want to know the value of the cell of this source, and I want to know the value of the internal resistance of this source. So how it works here is that from this circuit, you are going to short circuit your load resistor. Step one, short circuit your load resistor. Short circuit your load resistor. You have this. This is 15 volts. This is 3 ohms. This is 12 ohms. This is A. This is A. This is B. All right. Now from here, we said we want to know the cell of this source. We want to know the value of the cell for this source and the value of the internal resistance for this source. Now, you are making use of the given problem, the given question. Now, from this question, short circuit your load resistor. You know, the idea of load resistor is that I'm meant to short circuit my load resistor. Given any circuit, your task is short circuit your load resistor. Use short circuiting your load resistor. This is what you have. Meaning from this circuit, I want to know my E, and I want to know my R. The E of this source, meaning when we say E, meaning what? Cell, right? Meaning I want to know the value of the cell for this source, and I want to know the value of the internal resistance for this source. Now, how do you calculate your E? Solving for your E is equals to 12. We are going to use the voltage divider rule. By voltage divider rule, meaning 12 all divided by 12 plus 3 multiplied by what? 15. Using voltage divider rule, I'm having 12 all divided by 12 plus 3 multiplied by 15, which is equals to what? 12 over 15 multiplied by 15. From here, 15 cancel out. I'm having what? 12 volts. Therefore, E is equals to 12 volts. So what it means is that from this circuit diagram, I've obtained the value of the source. I've obtained the value of the cell of this source, which is what? 12, which is 12 volts. Next up, I want to get the internal resistance. I want to get the what? Internal resistance. How do you get the internal resistance? Calculate the equivalent resistance of this circuit, meaning you are going to remove the source voltage. Removing the source voltage, you are left with what? 12 ohms and what? 3 ohms. Therefore, calculate the equivalent resistance. Resistors are in parallel, so calculating the equivalent resistance, the equivalent resistance, meaning 12 ohms parallel with 3 ohms. That is 12 multiplied by 3 or divided by 12 plus 3. 12 multiplied by 3, I have what? 36. 12 plus 3, I have what? 15. And the ratio of this will give us 2.4 ohms. Therefore, my R, which is the internal resistance, I have it to be 2.4 ohms. Meaning, in place of R here, which is unknown, I have it to be 2.4 ohms, right? Now, from here, let's answer the question. Question 1 says that, what is the value of the load resistor? What is the value of the load resistor? Now, from your circuit diagram of maximum power transfer, you can tell the value of the load resistor, right? From here, it is obvious that your load resistor is 2.4 ohms. The question is why? How do you know that your load resistor is 2.4 ohms? It is very easy, right? Following the theorem, it says that the theorem says that your load resistor is equal to your internal resistance. Since we've gotten the internal resistance of this source to be 2.4 ohms, meaning your load resistor is also what? 2.4 ohms. That's your first question. You've answered question 1. Question 2 now says that find the value of the load resistor that gives the maximum power transferred, meaning the dissipation of the power, right? We found out to be 2.4 ohms. Question 2 also says that determine the value of this power. Determine the value of this power. By formula, power is equals to I square R. Power is equals to what? I square R. Now let's get our I using the formula for maximum power transfer. And this formula says that I is equals to the cell all divided by the internal resistance plus the what? Load resistance. So let's substitute our value. We have that the value of our cell here is what? 12 all divided by the load resistance 2.4 plus 2.4. I is equals to 12 divided by 4.8. Therefore, I is equals to 2.5 ampere. Meaning we've gotten I is equals to what? 2.5 ampere. So this is equation 1. Applying equation 1, you have that equation 1 says that I square R. You've gotten your I to be 2.5, meaning 2.5 squared multiplied by what's your R? In this case, your R is what? Is it the internal resistance or the load resistance? Your R is equals to what? The load resistance, meaning you have 2.4. Though you can go with this or this, since the value, they are always equal. The value are always equal, meaning the internal resistance, the value of the internal resistance of your source is always equals to the load resistor. So you can go with this or this, right? Meaning that I have a 2.4. From here, I have 2.5 squared times 2.4, right? Now, input this in our calculator. We have 15 watts. We have 15 watts. So meaning that for question 1, given this circuit, we are asked to solve the value of the load resistor. We got 2.4. Then the value of the power transferred, 1.5 watts. So what it means is that for any other value of resistor lesser than 2.4 or greater than 2.4, the value of the power can give us 15. Meaning we can't get 15. We'll be getting a value lesser than 15, right? So what it means is that for any value of resistor lesser than 2.4 ohms or greater than 2.4 ohms, we can't get the value of our power to be 15 watts. The value of the power will always be less than 15 watts. So what it means is that when R is equals to 2.4 ohms, I'm having what? 15 watts, which signifies the maximum power of this circuit. This circuit, we have its maximum power only if the resistor is equals to what? 2.4 ohms. So the whole concept or the whole idea of maximum power transfer is that I want to know the specific value of resistor that will give me the greater, or you say the maximum value of the power of any given circuit. Alright, this comes to the end of this video. If you find this video helpful, do well to share your thoughts in the comment section. Give it a thumbs up and subscribe. If you are interested in joining our WhatsApp channel, check the description below to access the link. We give solutions to different questions of your choice. See you in the next video.